My name is Tim Sutton. First, I just want to say thanks for having me back here again. I really enjoyed coming here for the first time last year, and it's really kind of great to get to see everyone again. So we're going to be talking about Jenkins continuous integration for MacDevOps. I'm going to start this off with a story. So a while back before I started in IT, one of the tools that I used to do quite a bit of work with, working with video, was Handbrake. Anyone remember the old Handbrake icon? So Handbrake didn't do their releases too frequently, but I needed to regularly. I was keeping quite a bit of a track of what new features and fixes they were adding in the app. And I was doing it for some video-related work. And so because they didn't do regular releases, but they were constantly adding new features, I was constantly rebuilding the app from source. And that was kind of interesting, and it was an educational experience to learn a bit about how these build tools could work and build automation and that kind of thing. But the process was also tedious. So there would be this doing SVN update. You'd run their build scripts, and then this process would usually take a few minutes, 5 to 10 minutes, I think. And I was sort of getting used to this, but I still thought maybe there was a more organized way to do this. And I noticed at some point they started to post a website on this tool they were using called Hudson. And on this site, they would host, every night they would do a build of the latest source code so that I didn't have to keep maintaining this build setup on my computer at home. I could just go into this website and download the latest release. So that's what Hudson looked like. I couldn't find the actual website that they had up, but that's what the Hudson web interface looked like. So Hudson was run by Sun, and eventually Oracle acquired Sun, and there were some disputes about how this project was going to move forward, and there were some trademarks involved. So that project, they sort of forked it into a separate project, which they named Jenkins, and Jenkins is sort of, it evolved and became more popular, and Hudson project still lives on, but not with any of the same kind of popularity that Jenkins has. So fast forward again a few more years, I've started using Monkey pretty heavily in my day job, and I've started to just keep track on what new features or fixes are being added to it, contributing a couple myself. But to build Monkey, so that to build the latest version and to package up the application, I would have to go dig up a Snow Leopard machine or set up a VM. I'd have to get into that environment. I'd have to make sure that I've got Xcode 3.2 point something installed. And then I'd also have to go through that same process again of grabbing the latest code, building it, saving the package somewhere, installing that elsewhere. So I thought about that Jenkins project that I'd heard about a while ago. I managed to just quickly get it installed, and without too much work, I was able to get a project that would check out the latest Monkey source code, build a package, and then I could figure out how to sort of script, removing a bit of taking some metadata out from the build process, and it would render some HTML, and then it would spit out, it would basically just copy the results up to a web server, and I would render some HTML to go along with the commit information. And so that became this project that I've run. It's been over 4 years now that this website's been running, and it's been basically that's sort of how I whet my appetite for Jenkins and sort of different kinds of software build automation tools. So that's just to give you sort of an idea of how I got into this in the first place. But so I'll talk a bit more about what continuous integration as a thing actually is. It comes from the software development world, and it's a practice of just automating processes surrounding the software development process, so that whenever new code changes are done, they could be very quickly and easily reintegrated back into sort of a mainline code branch. So all kinds of tasks that will give you more confidence that you can continue working on and merging small changes of code. So this would involve typically running, building the project and then running tests at various sort of levels of sophistication, either unit tests or full performance or regression tests. Fixing more just sort of code hygiene issues like style, complying to certain style guidelines or dealing with warnings from the compiler. Kind of coming back to what Chris was mentioning earlier in the morning about the whole works on my machine thing, trying to define a more standardized build environment where that doesn't become a thing anymore, and that's sort of the one gold standard, and you don't have developers dealing with different issues depending on how their machines are configured for when they're building and testing locally. On a larger scale project, this might involve also, after these tests pass, this could involve automatically merging code from one branch to another, depending on the results of the build. And it could also involve dealing with more of the dependency relationships within the project itself. So if there's a component that's shared by multiple different projects, you can do things like when you make new changes to a component that other things depend upon, you can orchestrate other tasks that are going to happen after the fact that are dependent on that. So that's sort of the development side, or the origins of continuous integration practices. If we want to think about how those sorts of things would apply if we work more on operation side of things, so one obvious analog is that if you're using configuration management, and most of those tools they usually provide ways to test your modules or your cookbooks with other tools, like Test Kitchen, for example, is a way you can run unit tests, and you can also run tests that actually run in live environments on different platforms. Personally, like my product that I work with in my day job isn't a software product, but I just take that idea of any kind of long-running build task. I can think of that as any sort of automatable process that results in end product, and where there's some certain specific environment requirements just to be able to set that up, a specific version of an operating system or dependencies, that nature. As sysadmins, it's also really easy that we can, without realizing it, internalize a lot of knowledge that we have about our processes. So trying to, like a system where you can put a lot of that knowledge into code and run it somewhere that's exterior from your brain, and get rid of the sort of brain cycles involved in doing things just sort of by habit. And it also serves as documentation, so other people can actually look up and see what exactly is involved in some of these routine tasks. And finally, a system like this Jenkins server, for example, there's many ways that you can delegate access to other people, whether that's for somebody needing to be able to retrieve the build without you needing to go and do it personally for them, or being able to give somebody else to be able to actually deploy code to a system, but in a way that's sort of been configured and vetted by somebody in an operations team. So to get some more specific examples that are kind of more relevant to at least sort of Mac sysadmin community. So there's a lot of really awesome tools in the MacAdmin community, and one of them is the Imager project that Graham's probably talking about tomorrow, right? So it's really easy to be able to create a project that will just, for example, automatically pull down, automatically check whenever there's new Git commits, run a build command, and then archive an artifact. That's sort of like the simplest possible pattern. You could create a sort of task like this in a couple minutes, and in this case, all this does is it just runs a build. I specify that I want to archive the output from the build so that I can actually go back later and download those from wherever I am. I have another job here which actually builds the base image that I use. So that gives me some things like I can choose different parameters about the OS version or the build version. I can choose which machine it will actually run the build on. So if I have to be constrained by OS version, like it works with, like auto damage works, I can do that. So talking about just auto damage as sort of a really useful tool, one of the things I can do is build the latest auto damage as part of that build. So if Pear adds some new particular fix for Sierra, for example, I don't have to care about first building that separately and then getting it onto the machine. I can just put all those build steps into the CI system and keep track of that centrally. Another really cool example is people who work with Mac hardware typically need to use the installer for one or more things. So for myself, that involves building base images and the OS installer. So for example, I can take the OS installer and build an installer package with create OS 10 install package, and I can have that then feed into my Monkey repo. From that same input, I can also build a restore image, and then I can feed that into an imager or a Deploy Studio setup. And then again, from that same installer package, I could build a netboot image using AutoMBI or System Image Utility, and then I could feed that into a netboot server or BSTPY server. And then there could be even later tasks, like in the case for Monkey, it could rebuild my catalogs once that's been copied over. For netboot, it could reload the network images, something like that. On those lines, Nick McSpadden at Facebook's been doing this really cool project where he essentially has an auto damage build and he has a Monkey repo, but they have all these sites distributed globally where they have to actually build a large image at each site. So what he does is he uses this tool that sort of hooks into Monkey and essentially feeds an image that contains all the latest stuff that they have in Monkey, and then they just rebuild this image every single night. So a system like Jenkins could be a way to like automate and structure some of those tasks. And this project, because I'm upstage and I have to be able to say it, it's affectionately known as ADCB. I can't take credit for that, though. That's Pepin Brienne's invention. Okay, so another cool thing that I've found that I can use it for is just being able to monitor sources that I don't personally control. So one of the things I do is I monitor for the latest versions of Deploy Studio. Deploy Studio is a free tool, but it's not open source. And there's a lot of logic to Deploy Studio is actually all contained in scripts. So what Jenkins does here is whenever there's a new Deploy Studio release, it downloads it, unpacks the installer package, it extracts all the admin tools, and then actually tags a release with all of those files, and then pushes that to GitHub. And what that's let me do is I can actually do a comparison across different versions of Deploy Studio. And most recently, this was really useful because it helped us find that they completely changed how AD binding works on 10.11, and it's not in the release notes at all. So being able to get some insight and be able to actually refer other people to that, so it's just like it's become just a handy reference. And then the whole Git and GitHub diffing engine is all basically for free, and Jenkins just automates checking it, pulling it, and then pushing it back up with a tag. I don't do this, but I had a sort of similar idea that you could monitor for changes to Apple's own security definitions files. So like xprotect, their definitions for known malware, the malware removal tool, for example, will have changes over time depending on new known malwares that they would support. So those are just some specific examples from sort of talking about MacAdmin community projects. But whenever you were if you would try to implement a system like this, it's really all just about making small iterative changes. You can try to imagine any kind of manual process that you have right now in an organization and see if any of those processes could be instead just converted into code, into anything that you can automate one piece at a time. So you would just start with anything you can do and then see if you can encapsulate all the logic of that one thing into something like even just a shell script is a good start. The next kind of step out from that is that whatever environment might be required in order to actually run or do that task, then you can start thinking about how to automate that. So with Jenkins and other build systems, they have this notion usually of like a build slave or a node or a runner. And this is one way that you can isolate an environment that those tasks can run on. And those can be running on different operating systems, different machines. They could be running in Docker or in VMs. But just having a way to more quickly reproduce the build environment itself. Right, and then once you've got that point, you can go back to that process that you started with and look and see if there's anything which is hard-coded or anything that could be factored out and made into just a configuration variable. So like one thing people are used to seeing a lot of now with Docker files and microservices type systems is people just publishing different inputs that they would be able to accept for configuration. And in the case of this, if you're running a build of something, then you can also tell it what to expect for output. And then systems further down the line can look for that and expect to be able to find that somewhere. So just a few other kind of pieces of advice with this. So the whole process, we're talking about something that's iterative. So the point is that you just want to make it easy to make small changes, but for it to not be painful to make any of those changes. So it's never going to be a perfect system, and it's always going to be somewhat broken in some particular ways. And the closer you are to the system, the more you'll know, what's broken and what needs improvement. But that's okay. You have to accept that and just be able to continually improve. One thing that helps, especially if you're dealing with processes that take a long time or where there's instability, is just make sure that you're exhaustive about what you check and where you can cause the thing to fail sooner rather than later. For example, if you have build steps which are shell scripts, you can set an option in shell to be able to say, the first, so -e is fail immediately on any error. -u is fail if there's any environment variables that aren't set. So that's a pretty common thing I would run into sometimes, where I wouldn't notice that a build, I would notice eventually that it failed, and that it would fail because some environment variables were empty, but I didn't explicitly check. So that's a quick way to sort of catch anything that may have gone wrong prior to a build script, something that's internal to Jenkins itself, for example. Being able to test those is really helpful, and you'll just catch a failure faster, and it makes it easier to iterate more quickly. Software doesn't ever stand still, and dependencies often will break from underneath us over time. It's sort of like our health. So if we don't exercise, we get out of shape, and it becomes painful to exercise again. And if you wait a long period of time between some process that's very long and complex to run, chances are that when you end up having to run it again in 6 months, it won't just be one thing that you had to one thing that may have broken that you have to fix. It might be like 2 or 3 things that are not necessarily related, but if you have the opportunity to exercise these tasks more frequently, then you'll catch issues, and they'll be easier to fix, and at a time when when it's not urgent as well. In Jenkins, you define these jobs, and the configurations can get quite dense. But those individual build steps, Jenkins will let you configure these as either scripts in line or just calling them within a code repository. So it's best to try to keep the build steps, the individual steps, as short as possible, so that way the configuration isn't too hard to manage. And also a side effect is that if you end up putting a system like this together, you'll end up putting more of your code into source control, which has a lot of other good side effects. So you'll have the ability to review later who made what changes and when, and if something breaks, you'll actually have a log of when those things changed, and you'll have a much better insight on where to start to go looking. So just some more specific kind of patterns that are present across different continuous integration systems, but I'll just use Jenkins specifically as an example. So being able to configure a project as having many different configurations. So in a software project, you might have tests that you run in both a debug level and a release level, and you might have a whole bunch of different platforms or operating systems that you also want to run those on. So being able to define a job as having different configurations lets you expose different environment variables or different nodes that it may run on in those different configurations. This is an example from the OS Query project. They have like 6 different configurations set up on whenever somebody opens a pull request. So you can just see by the numbers there, or by the names, they're just different versions of CentOS, Ubuntu, and OS 10 that they're testing those on. The trigger mechanisms for the jobs themselves. So the simplest thing you can possibly do is you can just tell it to pull a Git repository or some other source code repository on a schedule. They support just a simple cron syntax. So that's an example where it will just pull a repo every 3 minutes. That could be useful if your master can't be like world accessible for one reason or another. If it can be, and you're using a service like GitHub or Bitbucket or some system that has the ability to do a hook, like on getting essentially a Git post receive hook. With GitHub, it's more fancy. There's a proper API for this, so you can set up a hook that will, depending on what event comes in, like a code push or a comment or a pull request, you can then point it to your Jenkins server, and you can install a plugin on the Jenkins server that will coordinate back with it and trigger a build whenever an event occurs. That Deploy Studio example I showed earlier, you can have Jenkins just monitor an HTTP URL, and you can have it monitor whenever it was modified. In this case, it's actually checking the content of the file itself. So that file just contains a version number. So as soon as Deploy Studio updates with a new version, this job will pick that up and use that as a trigger. And you can also have a script trigger, which will let you just run your own custom shell script or in whatever Python or Ruby script that you can define. Okay, if the script exits 0, then I want you to trigger a job. And yeah, back to that GitHub example too. You can also have it communicate as a bot. So this is an example from Homebrew. A maintainer can post in the issue. They can actually just say, "Brew test bot, test this please." And this bot's can be set up for basically every chat platform, so Slack or HipChat. There's plugins for all these things. So that system of having different slave nodes that connect to a Jenkins master, you can run Jenkins on a Mac, and you can have it running all the jobs completely self-contained. It's not necessary to have multiple systems, but the more sophisticated your needs are, then it's more likely that you'll have different nodes connecting to it. So it's written in Java. Like Jenkins it's a Java-based project, so the slaves would need to have a JVM. But there's different ways that you can then initiate the connection. So the master can reach out to the slave and connect over SSH as long as it has a private public key pair. More commonly, I see that if it's the master which is accessible and the slaves might be on internal IPs or dynamically provisioned, they can connect up through essentially just a jar file that you can download from the Jenkins web interface. If you're on a Mac and you need to actually run jobs when the machine is not yet logged in, like if you don't have the user logging in to a graphical environment, then you can set extra Java arguments like that one. So that way you can say that it's going to run headless, and it will actually be able to start when it's at the login window. Either of these connections where you have either master to slave or slave to master, you have to still explicitly set up those nodes one by one. So that can be kind of tedious if you'd like to be able to work with this in a more dynamic way. There's a couple other options. So there's a plugin called Jenkins Swarm, and the Swarm plugin essentially just lets you put a binary on any random machine, and you can store sort of a token with it so that it will have an authentication to be able to connect up to the master. And you can still have those different machines tagged with different labels, so that way your jobs still know how to target specific runners. But this lets you dynamically create slaves or different nodes as needed, and then not have to manage them, like micromanage them one by one. There's also plugins that will do dynamic Docker or EC2 slaves. Just essentially, as there is demand, then you can have it automatically provision a new node to run jobs on, and depending on whatever kind of logic you want. You can also, if part of your build process actually requires you to determine new information as part of the build, that's one of the things that I use in the Monkey Builds project. So there's a plugin that will essentially just let you define a bunch of environment variables in a properties file. And then that properties file, you just point it to a path that contains properties, and it will reload those things back into the environment. So I think, again, Chris was talking about in Docker the problem of you have different build steps to build a Docker image, and if you need to make use of an environment variable in a later step. So this is sort of their Jenkins solution to that problem. So if you need to derive an environment variable as part of one step, later on in this job, it publishes it over SSH to the web server. So I extract this variable called SSH target dir, and then a step that happens after the build process, which is archiving the installer to a web server, can make use of the same environment variable. So mvinject is basically just a trick to inject environment variables into the environment. So yeah, after the build, you can publish it to different locations. The publishing system is basically an abstract class that different people can implement plugins in different ways. So like the SSH publisher can know about how to connect to a remote directory, how to deal with the path. It can execute commands on the target afterwards. This is an example of publishing to an SMB share. So this publishes to a Deploy Studio repo after building an image. Ways that you can authenticate to Jenkins: you can set up GitHub access. So you can have it paired with OAuth and give access to anybody you want with specific rights. And then Active Directory, there's a similar setup. So like in this example, there's basically just role-based access control. So I can give myself in the middle, I can give myself all permissions, and then I could assign to a group that's right above there. I could give them assignments to be able to say, okay, you can read the configuration, you can build jobs, you can give them specific access, but perhaps maybe not reconfigure the jobs themselves. Jenkins is also a nice, convenient way to store credentials in one central place. So if you end up having a lot of different build systems, and those systems, build nodes, if each one of those nodes needs an SSH key in order to be able to, check out a private repo or an S3 key or something like that, you can just store those tokens in one place on the server. If they need to be changed, you can change them in one place. So obviously, you just have to make sure that your server, the server itself is secure, that you don't have unauthorized access to the file system. And then finally, a lot of these things are all implemented as plugins in Jenkins. So you can't really see that, but there's a ton of categories. There's, I think, over 1,300 different plugins in Jenkins. So. OK, so I don't have too much time, but I want to just quickly show you a couple examples from, this is my actual Jenkins instance at work. So this is what the interface looks like. This is a list of all the different jobs that I have. On the left hand, you can see I've got different build nodes. So there's the master. There's a couple different versions of OS 10. There's even a Windows 7 build node, which is used for something. So there's a job, for example. So this job just creates an OS 10 installer package using Greg's Create OS 10 installer package tool. I can click on the workspace and actually get a live view of the file system on one of those build machines. So if I need to debug something, I can quickly see. I can get visibility into it that way. If I want to see what it actually looks like to start a build, and I say build with parameters. I've configured this job to have different options available. So if I ever need to make updates to any of the support scripts or packages that come with, that are built as part of that image, it's really simple to be able to go back and rebuild an older OS version if I need to. So like this is just an example of how it would look when you start a build. And then once the build is running, what's nice is you can just view the live console output right away. So there it's just building a few required packages. It clones the latest code from Create OS 10 install package. And then you'll actually see what this does if I look at the configuration. After it does the build, I tell it specifically what to archive from that. So there's the configuration for those parameters. So it's parameterizable in this case. You could add as many as you'd like. I restrict it to run on a specific build machine, which is my LCAP machine. And then here it's a private repo that it actually checks out the build scripts from. So there I can just point it to which credentials I want it to use. It can test them right there to let you know if the credentials work before you actually go and try the job. And this job is fairly straightforward. So the only command is actually just to run this one script, which is part of the repo that it cloned down at the beginning. That script does basically put in comments what that output, what we're expecting the output from that script to have, what we expect for inputs. It ends up writing some dynamically extracted information to this properties file. And then that's the end of the build step. And then I have a couple different post-build steps. So one of them is to copy it to my monkey repo. And I can define multiple transfer sets. So there it's copying the disk image. There it's copying the package info plist. The script also handles setting the package info in a specific way that I want. And then the second step is that it also copies the package to a Deploy Studio repo. So I can take the same product, and with one command, I can have it build a version which is wrapped in a disk image, build a version that isn't, and have them copied to different locations. And this configuration of the repo lives in the Jenkins master config. So you can very easily have other jobs connect to the same place. And you don't really have to, you just have to change the credentials in one place if you need to update them. If I look back again at that build, yeah, you'll see it actually like completed. There's the progress output from create OS 10 install package, and then the longest process is usually wrapping it in disk image and actually copying it to the repo. But the advantage here is like I didn't have to write any of the code that actually has to do with doing the SSH transfer or the CIFS copy. And it's one of those things where it doesn't seem like it's that complicated, but then you'd run into various edge cases and have to deal with handling the errors. So in this case, it's nice that I can just defer that to a Jenkins plugin instead. The example of the monkey builds project is pretty similar. None of these jobs are too complex, but you can see, if I go back up here, because this project actually archives artifacts, like any of the archived artifacts, I can just download them quickly right here within the web interface. The logic, or the part of Jenkins which does the git clone, there's also tons of additional behaviors you can configure. So the only one I have right now is just if as remote branches get deleted on GitHub, then this will also keep track of pruning them locally so that I'm not, if I tell it to rebuild all the branches, it's not going to build a whole bunch of branches that don't exist or that are stale. In this case, I'm just doing an SEM pull. This repo, or this Jenkins instance, it's not publicly accessible. So I have to just do git polling, at least for now. There's the full script, actually. So that should be refactored into like a single line, right? It's better to be able to actually have that in source control. For now, I actually just have a copy of it. So that should be fixed. But there's dynamic properties that are assigned to a file. There's the HTML that gets generated. There's where I specify all the different artifacts that I want to save from that job. I can define an email notification that's going to send me an email if it fails or succeeds. And then there's that part that transfers it to the web server. If there's a branch, if the branch that I built was master, then I actually just update a symlink. And that symlink is actually what, if you use auto package to pull in monkey packages, that's what it reads. And lastly, I also just post it to Slack. So there are plugins that will just automatically notify on pretty much any other IRC or Slack or any other platform. In this case, I'm actually doing it with curl because I wanted to customize exactly the output that it has. But yeah, so that's, I think, yeah. And I mean, the reason why I have a Windows VM, for example, is kind of getting back to the talk about Python and packaging is this project that I maintain is actually, one of the outputs is a Windows binary. And I use PyInstaller to build that, but I don't work in Windows daily, so I'd like to just be able to have that environment sitting off somewhere available, and part of the build script will configure most of what the dependencies for that build are. So worst case, if that VM gets trashed, I can recreate a new one and just connect it up to this Jenkins master, and I can just connect it to run the same job again, and it should all just work. So yeah, I think that's all I've got time to show for that part of things, but we'll go back and finish up. So you saw a bit about what the Jenkins web UI looks like. It's not that fun to try to manage that on any large scale, right? So it's very much kind of a point-and-click interface. You can automate pulling all the configuration out and putting it back in through a command line tool, and there is a JSON-based API and an XML API for working with it, but there's a couple other options. So one of them is a plugin called the Job DSL. What it is it's a DSL that's implemented using the Groovy scripting language, which is sort of a Java ecosystem scripting language. This is an example from a project that I used to maintain. I've stopped maintaining it, but what it was a public Jenkins instance that just ran auto package recipes. And this was basically all I needed to describe a job. So at the top, it would read, so auto package would list all the recipes, and then it would parse this file, which contained a list of all the recipes. For every line in the file, it would, let's see if I can, yeah, it would describe what the job is, give it a name, tell it. Actually, they would all run using auto packages, current Git master code. So it was one way to pick up any issues with changes to auto package itself, define the schedule, and then define the actual script that would run the job. So and this would end up generating over 100 different jobs. So this would actually look like what the output would be. So if I ever wanted to make just one change to those jobs, I would only have to update that one small Groovy file and then rerun a job that would actually then update all the other jobs. So the weird thing about the DSL plugin is that it is implemented as a step that you run as a job. So you sort of have a job that generates other jobs. That plugin is really actively maintained, but that setup is a bit, and if it seems weird, then what you can also do is you can, there's another project called Jenkins Job Builder, which is maintained by OpenStack. And that's a Python-based project that is basically just a command line tool. You describe the job as a set of YAML files. You can template out part of those YAML if you want. And then that's just a very easily scriptable way to maintain a whole set of jobs. And then you don't have to necessarily have so much complex logic in the job itself. If it's easier to just splat out 100 different jobs according to some logic, then this is maybe a better solution. And then if you want a better way to manage Jenkins itself, either the jobs or any kind of orchestration at the level of Jenkins, there's wrappers for sort of all the popular scripting languages or sysadmin type languages. Those are all wrappers for the API. So what's kind of interesting to me is where this could go if my spinner will stop spinning. I think it didn't like the camel. I think it was the camel that did it.
What's going on the upper right?
Go.
Oh.
It's the gopher.
Gopher.
Yeah. Wow. All right. That has never happened to me. Like, it is totally, there we go. All right. Let's try that again. Spinning. That's it. Okay, it's coming up. Reopening Windows.
Should we take some questions?
Yes.
Questions? Anyone questions for Tim? Okay, there's no questions. I guess we can just. Oh, here you go.
Mr. Cobb?
Hey Tim, what's your least favorite thing about Jenkins?
The fact that it's in Java it can be a pain point, but I think the biggest thing is that because there are so many things which are implemented as plugins, there's so many moving parts to the system, right? Like it is a tool that can do pretty much anything, so it's definitely not some narrow, sharply focused tool, right? So I do find that because there's so many plugins, all the different functionality is implemented as plugins, that you will do updates to plugins and weird things can break, right? It's sort of like, and there are like the LTS releases of Jenkins, but because those releases still rely on plugins for some core functionality, that's always the thing that makes me nervous. Is like there are times when I do a plugin upgrade and then I just start noticing that a build starts failing because of something that plugin broke, just to do with like the Git poller or something like that. A couple weeks ago, I upgraded something. And it was I think it was a third-party plugin, but it might have been a core plugin. But anyway, a minor plugin update broke like a really core part of Jenkins, and then it was fixed within a day. So it wasn't like that was a pretty bad case. But yeah, I think that's the biggest thing, is just dealing with the upgrades. I think that to maintain it in a production environment, you would more need to you need to have at least a decent sized like second instance that you can test all your upgrades. So you'd end up needing to be doing CI for your CI at some point. But with each one of those things you'd end up doing, you would get better reliability. It's just that it becomes more work and more of a pain. Keynote is hosed, like it doesn't even launch. And I'm not running Sierra. This is actually just a desktop background. Yeah.
Mine's a question.
Any other questions?
Tim, question. How much oomph does your Concordia CI server have?
Sorry.
How much oomph, like IO ops?
Because
like some of those steps you have there, they're pretty IOPS intensive.
They are, but the thing is, all of those tasks run on various Macs that are elsewhere. So like the server itself is just a Linux VM. Okay. And the Macs, are typically, I try to at least make sure that they're machines that have SSDs and
Gotcha.
Are at least decently powered. But I mean, most of the things that I run are mostly IO intensive, and most of the modern Macs with the PCI SSDs that they have, they're pretty good. I have run into cases where if you run so many jobs over a long period of time that you can like fill up your inodes on the machine, because there's so much accounting that comes with every single job run, like saving all the log, right? All the console log, and so you do want to purge. You want to make sure that there is some kind of log rotate happening within Jenkins itself. But like one of the things that you can configure in the jobs is that you can tell it to keep only the last so many builds, or keep the builds for the last 2 months or something. So that's one way to kind of make sure that your master doesn't run out of disk space or other resources.
And do you normally separate which jobs go to which nodes so you can have some sanity?
Yeah, well, so you get to define. I'm rebooting. You get to define what logic you want to be able to do that. So, for example, to build a disk image with auto damage, it actually has to be pinned to a specific OS version. But you could very easily have logic that runs as part of the job that would like dynamically determine which machine to run it on, based on just the input parameter that I give it as to which OS version. And then there's also ways you can make it so that you can select it at the time if it's an ad hoc build, or you can define, this thing should always be made available to run jobs, or it should only run one job at a time. If you run tests that involve like the iOS simulator, for example, you need to do some things like not run other jobs at the same time that might end up having to call the same simulator, those things like that. Okay, well, my machine's come back up, but I'm pretty much out of time, so. Do we have like 5 or 10 more minutes if I can get Keynote back up?
That's not enough time for Alice. Yeah, I only had a question about the DSL plugin, if you had actually made that available since you took ci.autopackage.
It's actually online still. So the code for all that is, and I have a blog post that I'll post at the end, and that has a link to it.
Sure, great, thank you.
Yeah. OK, so I did manage to get it to come back up. Basically, the last thing I wanted to point out is that these examples that I showed on my system are really simple, right? They're pretty trivial. You could sort of think of them as glorified shell scripts at some level. But it's pretty impressive to look at a system that actually is more mature. So one that I liked looking at recently is how much the Homebrew project has developed their CI system. So on the left hand is all the different steps that run every time somebody submits a pull request or makes any updates to a pull request. And then they run those jobs across the 3 different versions of the OS that they support. And then after they run all these tests and they verify that all the build is successful, they end up archiving the built products into a tarball. They end up triggering a downstream job, which is to actually copy that bottle over to, I think it's bin tray that they use or wherever they're being stored long term. And then eventually a maintainer ends up just getting a notification that, OK, there's this thing waiting in the queue. It looks all good. Tests passed. And then that maintainer can just approve it, and then it goes into their production repo. There's another project called Concourse recently released by Pivotal Labs, and this is more just an example of how everything is going more towards pipelines. So not focusing only on the kind of test and development cycle, but also providing ways to carry the product all the way through like a staging environment and then to production, and giving more sort of logistical controls about how that happens and who's allowed to push the button. Jenkins has actually, maybe 4 weeks ago, they announced this project called the Blue Ocean. And this is sort of like a new UI design that they're working on to sit on top of the Jenkins pipeline system. So the Jenkins recently had a 2.0 release where pipeline is sort of a native construct instead of just a plugin. And so this is sort of where the Jenkins project is heading as well. And this is just where you can go to get Jenkins. It's a package installer on the Mac if you want, or you can get it with Homebrew. And I have a table of other platforms that you can look at in more detail. I'm going to post the slides afterwards. And there's just sort of a summary of different options that put part of it into the cloud, part of it let you bring your own runners. There's a lot of different options there. So yeah, thank you.